All right, if you're working with a cloud data platform like Snowflake, you know that feeling, right? That constant tug of war between getting your answers fast and keeping your spending from spiraling out of control. Well, today, we're handing you the playbook to finally win that battle. So that leads us to the big question, the one that's probably on your mind. Is faster performance always more expensive? I mean, your gut probably says yes, right? But, and this is the key, that's often wrong. We're going to show you how, counterintuitively, you can sometimes get faster results for less money. It's all about knowing which dials to turn. Okay, before we go any further, there is one single foundational rule you just have to burn into your brain. It's this. In Snowflake, compute equals billing. That's it. Storage, super cheap, but the actual work your system does, that's the compute. And that's where the bill comes from. Everything we're going to talk about today circles right back to this one simple fact. So here's how we're going to tackle this. First, we'll look at the performance cost puzzle itself. Then we'll get into tuning your warehouse engine. After that, we'll talk about handling that dreaded query rush hour. Then we'll cover smart storage for cheaper queries. And finally, we'll put it all together into your optimization playbook. Let's jump in. All right, let's talk about the first and maybe the most important dial you can turn, the engine. We're talking about the virtual warehouse. This is the thing that does all the actual work, all the heavy lifting. And getting the size of this engine right, that's your first crucial step to winning this whole performance versus cost game. So think of your warehouses like t-shirt sizes. You've got everything from extra small all the way up to extra large. Now, an excess warehouse, it costs less per second, but it's going to struggle with those really chunky, complex queries. On the other hand, an Excel is an absolute beast for huge data sets, but yeah, it costs more per second. The key takeaway here, bigger isn't always better. You don't always need the biggest shirt. It's all about matching the size of the engine to the size of the job. And that's precisely why it's a huge mistake to just have one giant warehouse for everything. The smarter strategy is to create separate, specialized warehouses for different jobs. You might have one dedicated to your heavy ETL transformations, another one just for BI and reporting, and maybe a totally different one for the data science team's ad hoc queries. This way, they're not all fighting for the same resources, and you can optimize the cost and performance for each specific task. Now, here's a feature that is an absolute game changer for saving money, Auto-suspend. You can set a warehouse to just turn itself off after, say, 60 seconds of doing nothing. The second it suspends, the billing clock stops, cold. You are literally not paying for it anymore. And when a new query comes along, it wakes right back up, almost instantly. It's such a simple idea, but it's unbelievably powerful for cutting out wasted spend. Okay, so let's move on to our second dial. What happens when everybody logs in at 9 a.m. on Monday morning and starts hitting run on their dashboards? You get a traffic jam, right? That's the query rush hour. And to deal with that, you need a traffic controller. And this is where multi-cluster warehouses are just brilliant. See, instead of making everyone wait in a long line, as soon as Snowflake sees queries starting to pile up, it just automatically spins up a brand new identical cluster to help with the load. The work gets spread out, and then, and this is the best part, once the rush is over, those extra clusters just shut themselves down. You only pay for that extra horsepower for the exact minutes you actually needed it. So this really gives us two totally different ways to scale. You can scale up, which means getting a bigger, beefier engine. That's perfect for when you have one single, monstrously complex query to run. Or you can scale out, which means adding more engines of the same size. That's the go-to solution for handling tons of users all hitting the system at once. Knowing when to scale up versus when to scale out is absolutely crucial. All right, so we've talked about the engines. Now it's time for our third dial, and this one is all about that old saying, work smarter, not harder. Let's call this one the organizer, because how you physically structure your data on disk can have a jaw-dropping impact on both performance and your final bill. And the secret sauce behind all of this in Snowflake is something called micro-partitions. Basically, behind the scenes, Snowflake is automatically chopping up all your data into these little 16-megabyte compressed files. But here's the magic. Each tiny little file keeps notes about what's inside of it, like the smallest and largest date or the lowest and highest customer ID. This metadata is the secret weapon for a technique called query pruning. Now, to really get why this is so important, just imagine this. I hand you a 1,000-page book, and I tell you to find one specific sentence somewhere inside it. But the only way you're allowed to do it is to start at page 1, word 1, and read every single word until you stumble upon it. I mean, it would take forever, right? It would be horribly inefficient. Well, that is exactly what a database is doing when it has to do a full table scan. It's just brute force. But because of those clever micro-partitions and their little notes, Snowflake can be way smarter. It uses that metadata like the index at the back of the book. So if you ask for data from last Tuesday, it can look at its index and instantly know to ignore the 99% of pages or partitions that don't have any data from last Tuesday. That's pruning, and it saves a ridiculous amount of work, which saves you time and, you guessed it, money. Okay, so let's tie this all together into a quick little cheat sheet. If you're seeing this problem, a single heavy query is just crawling. The solution is to scale up the warehouse. If you see this problem, your query is scanning way too many partitions. The solution is to improve your data clustering so pruning can do its job. And if you see this problem, tons of queries are just sitting there, queued up. That's your cue to use a multi-cluster warehouse and scale out. All right, let's get to the final section, putting this all together into your personal optimization playbook. These are the big takeaways you can start thinking about today. And it all starts with this one simple but really powerful idea. The fastest query is the one you never run. And how do you pull that off? With some very, very clever caching. First and most amazing is the result cache. It's basically magic. If you or anyone else in your company runs the exact same query and the data underneath hasn't changed, Snowflake doesn't even bother running it again. It just hands you the result from last time, instantly. No warehouse even turns on, zero compute cost. It is literally free performance. Next up, we have the metadata cache. Remember all those little notes we talked about on the micro partitions? Well, this is the cache that holds all of that information. It's the reason Snowflake knows which data to skip before it even bothers the warehouse, making that whole pruning thing happen in a flash. And third, there's the data cache. This one's a little different. It's a temporary cache that lives on the warehouse's own hard drive. So if you're running a bunch of different queries that all need to read the same data, this will speed things up quite a bit. The one catch, this cache gets wiped clean the moment your warehouse suspends. And look, beyond all the fancy caching, sometimes it just comes down to good old-fashioned SQL habits. These are the quick wins. Always use your where clause to filter data as early as you can. Please, stop using select star. Just ask for the columns you actually need. Be really careful with expensive operations like distinct and order by. And finally, use appropriate data types. It really does make a difference for storage and for pruning. So there you have it. You're not just a passenger on this platform. You're the pilot. You have the controls. You can tune the engine size, you can direct the traffic, and you can organize the data. You now have the playbook. So the only question left is, which one of these dials are you going to turn first?